Testing, testing. Hello, Miami. Can you hear me okay? Well, I wish I could be there in person, and I don't think I've ever been more sincere when I say that, but I hope you're having a fantastic time, and hope you can enjoy my presentation about testing and how that distinguishes IDDSI from everything else. So it's always been a cornerstone of our IDDSI framework that our texture levels are defined by objective measurements rather than subjective descriptions. These measurements don't require specialist training or equipment. They were designed to be accessible to the widest possible demographic of ages, setting, and cultures around the world. So in this presentation, we're going to focus on those measurements. There are three parts, and I'm going to start with part one. What are we trying to measure? So firstly, an introduction about textures, foods and drinks, and why they're relevant to swallowing. Well, I always like to focus to start with on the mechanics of swallowing. First, highlighting that swallowing is an interactive mechanical process. On the right of this slide, we have a conceptualization of some of the forces that are at work, and I always like to note that the bolus only moves in response to the forces that are applied to it. So that also includes gravity, which would cause the bolus to spill off the tongue if it were not for the tongue forming a nice cup shape. Then the tongue also provides compressive forces against the palate, and that causes the bolus to move. So the speed that the bolus moves at then is a result of those forces that are being applied in combination with the material properties of the bolus, and that includes viscosity and texture. And so those are the properties that we're going to be looking at in more detail through today's presentation. But as I say, it's an interaction, so the forces that we apply muscularly are governed and controlled by the sensations that we feel. So we feel, move, and that movement generates more feelings. So in that way, it's an interactive process. So on to textures then. Well, here's a nice selection, and whether you suffer from dysphagia or not, we all like to consume foods and drinks whose texture has been carefully designed and controlled in order to make it appealing and easy to eat and drink. These four drinks will all be consumed in different ways, as I'm sure you can appreciate, and it's because of the sensations that we feel in our mouth as we're consuming. They have a strong influence on how we would then go ahead and swallow that bolus. That relationship's been studied in great detail by Professor Katrina Steele. She's done some great work on the swallowing process, and in this particular publication, she was giving evidence that tongue pressure is strongly influenced by thickness, and so also was the sip volume that these volunteers took. I was lucky enough to be involved in this study, and we used a range of IDDSI standardized textures, as you can see by the color codes there. Now that means that our results can be duplicated by other labs in other slightly different situations, different population groups, for example, but also, perhaps more importantly, those results can be translated directly into practice. They can be implemented in any setting, any care setting or bedside. So that takes us from the lab to real people. Now back to the question of what do we mean by thickness. IDDSI has a scale, but that wasn't very easy to come by because all liquids and solids have several different properties. You might have heard of the term viscosity, and that's one way to define one specific characteristic of some liquids. But real foods and drinks have a range of different properties. This gum-thickened drink on the left doesn't really compare very well with the oral nutritional supplement on the right, which forms long strands, despite those both having the same measured viscosity in the lab. So it's the test conditions that really determine what is important in characterizing the material. Viscosity is one very particular, specific and limited way of measuring the thickness of some fluids. It only applies though to water or some Newtonian fluids like honey or oil. But for everything else, including most foods and drinks, they're non-Newtonian, and it means that they can't be described by one measurement of viscosity. like the difference there between the gum-thickened liquid and the oral nutritional supplement. That's a good thing, though, that they are more interesting, and in many cases it means that they're more easy to control and swallow in the mouth, so that they hold together but they don't require excess effort to swallow. As well as being Newtonian or non-Newtonian, there's lots of other characteristics which make, in particular, thickened drinks much more of a challenge to define. This thickened water has an elasticity to it, which we can clearly see there as it bounces back from the deformation. So how we can measure this in the lab and in practice? Well, in the lab, back at my university, we've created an oral mechanical simulator where we've got a model of the tongue compressing a fluid against a hard palate, which has got pressure sensors. This is not quite like the human body, but it does have the advantage that we're able to take precise measurements of pressure and flow. And in particular flow, we can really slice through the liquid, zoom in. We're using a laser to illustrate little particles within the flow and capture that flow field so that we can get some precise measurements about how the bolus moves in response to pressure. Unfortunately, we can't get that sort of measurement in the mouth. So IDDSI's come up with a great system of then how do we take those sorts of detailed lab measurements and translate them into something that's simple, very inexpensive and available around the world. So part 2, how do we measure that? How do we measure texture, viscosity, fluids and solid foods and drinks? Well, some of the studies that have been done over the years include measuring viscosity. And as I mentioned, viscosity is a technical specific lab measurement, but it's actually too simplistic to describe the overall behavior of foods and drinks. The graph I'm not going to cover in detail, but suffice to say that there are lots of different points at lots of different places on that viscosity graph. And that gives an indication that under different test conditions, the measured viscosity of different types of liquids will vary, and it can vary enormously by a factor of 10 or 100. So it's very difficult to isolate one particular measurement that represents everything that's involved with swallowing, because we have a range of different conditions that are relevant, from taking a sip in the cup, swirling a liquid in your mouth, compressing it, and then swallowing it. So in practice, we need something that captures more than just one specific isolated test condition. And here we have some examples of more practical viscosity measurements or consistency measurements. These were things that IDDSI considered. So, for example, the Bostwick and line spread test do have some history of use, but they seem to measure a slump of a semi-solid liquid rather than the faster flow rates that are involved in typical swallowing. Which include not just shear but extensional flow. So bearing all that in mind, and with several iterations and tests and feedback and consumer trials, IDDSI came up with this flow test based on a funnel, and the funnel that we used in the first place was a syringe. Of course, nowadays we've got IDDSI funnels, and we'll cover those in more detail later as well. But there's a paper referenced here which covers the design and testing of that test, of the IDDSI flow test, showing how it relates and how it measures different types of fluids. So we needed to be able to measure Newtonian fluids such as gums or syrups, but such as syrups or honey-like liquids, sorry, not gums. But we also needed to be able to measure very non-Newtonian liquids like gums or starch-thickened liquids. And of course, we then end up with the famous IDDSI flow test. You're going to hopefully leave the conference with a funnel if you don't have one already. And the process is then that you cover the end of the funnel with your little finger, take some practice to get used to this, fill the funnel up to that 10 milliliter line, and when you're ready, release your finger, time 10 seconds, and the faster the fluid flows, the thinner it is. So after 10 seconds, you stop that nozzle again and take a measurement. And in this case, The liquid remaining is between 1 and 4 mils. That's in the IDDSI level 1 category. So here we have an IDDSI level 1 fluid. So that test takes 10 seconds, and these funnels are highly reusable. Just a quick note that we designed that size and timing of the test in order that the scale of 0 to 10 matches a whole range of fluids that we'd call drinks. So everything from water up to extremely thick liquids that wouldn't float. And a note that for IDDSI level 4 liquids, you would need to test those with the fork and spoon test instead of the IDDSI funnel. Again, we'll come on to those in more details later. So it's important to use the correct geometries. There are some other geometries out there, and we would recommend using the IDDSI website as a guide for which syringes are possible to use. And of course, we have the IDDSI funnel, which is, as I say, much more reusable, much longer lasting, and has the benefit of being able to be filled much more easily. It also has quite a significant benefit for clinical situations in that it can't be confused with a syringe, which would be used for intravenous use. So it's quite a bit safer in that respect too. So that's the IDDSI funnel-based flow test for measuring thick liquids. And we then move on to how we can measure the textual properties of foods, which is in a lot of ways a lot more varied. So one of the characteristics that we can look at is cohesion, the ability of a material to hold itself together. And it's proposed that this is quite a useful feature for avoiding accidental spilling or aspiration while swallowing. We can measure it in the laboratory, but again, it's not very straightforward, and measuring cohesion precisely is quite a specific and not very relevant to the real world test of swallowing. Again, in the UCL lab, our mechanical mouth, we've been able to measure some aspects of cohesion. Again, this is not related to clinical data, but we are able to identify some interesting features. In particular for gum-based thickeners, we found that as the bolus was compressed, we'd get this initial peak in pressure, followed by a little bit of a dip in that. And by inspecting the video, what we found was that after the bolus is leaving the back of the model tongue, once the head of the bolus starts to drop off, it's actually dragging the tail behind it, which is reducing the pressure on the palate, but also keeping the bolus as quite a coherent whole. So this was in contrast to starch-based fluids, which didn't show that property at all. Now, although this is very simplified geometry, it could be indicative that that's quite a useful feature of gum-like, jelly-like liquids, that they hold together for swallowing. Clearly, we need a lot more clinical research there, but it's an indication that studying cohesion could be quite a worthwhile thing to do in order to better understand the relationship between texture modification and dysphagia. So cohesion, the ability to hold together. Another property that we might be interested in is adhesion. Now, this is not necessarily a good thing, because we do want the bolus to stick together, but we don't want it to stick to other surfaces. In particular, while swallowing, that could leave residue at any part of the swallowing process. So IDDSI's task then was to create real-world, non-lab-based tests for cohesion and adhesion. And this is where the fork and spoon tests arose from. The fork test being a test of how well a material can hold together, and the spoon test a test of a sort of standard operating procedure to identify whether a material would be too thick and sticky. So to be suitable for IDDSI, the foods need to be able to slide off the spoon, leaving very little residue, and that should give an indication that the material would be easy to swallow without leaving residue. IDDSI also has a definition of softness, being the opposite of hardness. Now, this is again something that you can measure in the lab, taking measurements, but we needed to recreate that in the real world without requiring motors, sensors, or anything that can compress and squash foods. Quite a challenge, and that's where we came up with the fork pressure test. So in order to quantify the pressure being applied, we couldn't just say press firmly or press gently. We used the concept of blood pressure, and by applying enough pressure with your thumb to overcome blood pressure, leaving your thumbnail slightly blanched, that gives an indication of a certain relatively constant pressure between individuals. And that we found was about 17 kilopascals, plus or minus a good degree of variability. But that corresponds to about the same pressure that the tongue is using, generating a swallow reflex. So it's got some physiological relevance there. And food is then defined as soft if it can be squashed and crushed with less pressure than that which causes the thumbnail to blanch to white. The sample also needs to not return to its original shape when the pressure is released. So marshmallows, though subjectively would be described as being soft, they do not pass that IDDSI fork pressure test, and that gives an unambiguous indication that marshmallows are not a soft food suitable for someone with dysphagia to be swallowing. There's a slight tweak to this test that the more interested of you can do some research with and have a play with, if you like, in your kitchen laboratories. This was published in a recent IDDSI e-bite, and the concept is that rather than purely relying on the visual observation of blanching your thumbnail, you can use kitchen scales to measure the force that you're applying. And we found that about 390 grams force is equivalent to 17 kilopascals, provided that the material size is 15 by 15 millimeters. So check the IDDSI e-bite and the IDDSI website for more details on that little addition to the test. I must say this is certainly a very optional enhancement to the test. It's not, we don't expect everybody to do this, but the slightly more scientifically inclined amongst you, it can give us slightly more reliable and quantitative measure of the pressure. On to then how you'd use the test. I must emphasize IDDSI is a language and not a law. There's nobody requiring you to do this. And likewise, the IDDSI tests are not a textbook for treating, managing dysphagia. It's clinical judgment that always remains the priority in assessing and designing management strategies for dysphagia. IDDSI's purpose there is to give you a standard language with which to communicate between different caregivers and clinical staff. IDDSI can also give you quantitative measures which you can use. For example, the functional diet scale can allow individuals' progress through their dysphagia journey to be tracked and recorded, or the tests can be used within institutional kitchens or laboratories for auditing and research. So they do have a purpose there. And that brings us on to the third part. Why should I be measuring at all? Once I've got things set up, and do I need to measure? Well, not every day necessarily if you do have reliable processes, but we're going to see many reasons why there can be sources of variability in textures. The first, if you're using thickened drinks, and whether you're using powder or even gel dispensers, it's important to concentrate and take account of the measurements that you're using there. So for powders, it's important to use a standard measurement. The scoop is good, but make sure you level the scoop off, and notice that even if you do that, there's still some variability within the scoop depending on how firmly you can press the powder in there. In the lab, I tend to use scales, quite high precision scales there, to weigh the powder that I'm applying. I don't expect everybody to do that, of course, but just to make you aware that if your scoop size is varying, then you should expect some variability in the fluid thickness. And that's where the IDDSI tests are brilliant, because they give you that opportunity to test the liquid after it's been created. Likewise, measuring liquid, you may remember this from school. when you're taking a measurement on a beaker, it's important to get your eyes level to the liquid measurement. And so in this case, I'm illustrating that the observed level could be between 90 and 100 milliliters, depending on where you take that measure. So you need to be consistent in that measurement. Also, the type of liquid that you're thickening with thickeners can vary depending on the brand of thickener and also between the type of liquid that you're thickening. In this study, the investigators found a factor of 4 difference between peach grape juice and coffee. And in previous work, I found a factor of 10 difference between a very wide range of beverages thickened there. And this was me putting white wine and beer on my expenses account at university, which raised an eyebrow or two. So there are external factors that can affect consistency in drinks, and this is not the season for oatmeal, but in Scotland, where I hail from, oatmeal or porridge is a very popular breakfast and gives a natural experiment. So here's a delightful oatmeal breakfast, rather thick, perhaps even too thick for the IDDSI spoon test. But if it's just been contaminated with a tiny bit of saliva, and this is a coating on a spoon's worth of saliva, this is not me taking a great big spit into the bowl, then you can see the consistency dramatically changes. There's something you can do about that though, adding a teeny bit of gum-based thickener and then contaminating the porridge again. The consistency is very much still retained. So there can be lots of factors that can affect thickness, and taking measurements using the IDDSI tests can allow you to quantify that. Temperature is a famous source of variability for liquids, even water, and it's even more noticeable for liquids with a high sugar or fat content. Here we see custard, but nutritional supplements are just as prone to that effect. So since we can't guarantee the thickness or texture of foods and drinks, it's really important that we're able to measure in practice. For anyone interested in taking these IDDSI tests to the next level, I've already given some examples of how you can use it in research. Our framework paper has been very, very widely used within research. There were 17,000 downloads in the first year, and now we have something like 800 Google Scholar citations of this work by other researchers using and referring to these tests. So there's an awful lot of science out there. The presentation's maybe been about the science behind IDDSI, and this is an indication of the science that's in front of IDDSI. It's going forward and allowing scientific research, which then has direct applicability to the bedside, because of course you can use these results without being a scientist. So here are a couple of examples of the IDDSI tests in current research. Very diverse examples from 3D printed foods where the IDDSI tests were used to characterize whether they met the IDDSI criteria, and in this case some of them did meet the criteria for IDDSI level 6 and 7 soft. And that in contrast to Marilisa's paper with my esteemed colleague Mershon Pillay, where this was in sub-Saharan Africa, in local communities with no electricity or running water, but using the same IDDSI quality tests. An area of research, and the gross out warning here is for some chewed food pictures, an area of research that we're really interested in is using IDDSI to quantify the food oral processing practice. Some great work by former IDDSI colleague Jianxi Chen and his laboratories, where they're looking at textural properties in relation to oral sensations and triggering of swallowing. IDDSI tests are used in lots of different foods and drinks, from geriatrics, as we're mostly aware of, but also pediatrics. Really interesting new products becoming available there, and particularly looking at the flow through infant feeding bottle teats, where in particular for premature infants, this is really critical that they don't use too much energy in obtaining their nutrition and hydration. And using IDDSI in implementation. the IDDSI tests and IDDSI practices can be really effective at quantifying and giving examples and evidence of IDDSI improving the financial viability of management of dysphagia. Assessing new products from medication swallowing lubricants to new 3D printed or newly created materials and products. And so the IDDSI tests are used in research and can be used in a variety of situations, so do give it some consideration. If you'd like any further information on some of the materials that you've seen today, the IDDSI.org website is your first port of call, and we also have a YouTube channel which has got lots of examples of running the tests and lots of webinars that are up there still. So for now, I'll say cheerio from good old Blighty, and I wish you could be there, and I hope you have a fantastic conference. Thank you for your attention.